Alright, so today we're going to be dividing polynomials by polynomials, and we're going to start off with a basic one, which is just in this case, a cubic polynomial by a binomial. This is our typical starting point on this long division idea. We're going to be dividing by x plus or minus some number. Those are the easiest ones to do. The technique, as I just passed out to you a moment ago, looks like this. It's a lengthy technique. The nice thing about these, historically, students have done pretty well with these because every time you do the problem, you practice the technique 3 or 4 times. And it's a pretty straightforward process. It's long division that you learned back in 3rd or 4th grade. But now we're going to introduce letters to the mix. So we have a few algebraic rules we have to consider while we're doing it. All the same stuff we've been dealing with like terms and should I add, should I subtract, should the sign be positive, should the sign be negative, all those types of things are going to be showing up in these still. As we continue to do this again and again and again and again and again, this should become second nature to you if you're challenging yourself to remember the rules each time you do it. I added the numbers because the signs were the same. I got a positive because the positive number is bigger. I subtract because the signs were different. I got a negative because the negative number is bigger. If you rehearse those rules every time you do it, it becomes second nature. All right, and again, some of you already have that because you did what you're supposed to do back in Algebra 1. Some of you didn't do what you're supposed to do in Algebra 1. Now you're sitting here struggling in Algebra 2 because of that. So I'm telling you, the more quickly that you get done with this, the more quickly that you believe me that you have to rehearse the rules to understand the rules, the quicker this class will become easier for you. So first thing we do is rewrite the problem in divisor, dividend form, descending order, 0 terms. So what we're dividing by is called the divisor. And what we're dividing into is called the dividend. A 0 term happens on the dividend if there's a power of x missing. Okay, if you look at this, x to the 3rd power, x to the 2nd power, x to the 1st power, and constant, there's no power of x missing. So I don't have to worry about 0 terms in this one. So I'm going to write divisor right here, x plus 3, divided into the dividend, x cubed plus 5x squared plus 6x plus 9. That's priority 1. If this 5x squared weren't there, if it just an x cubed plus 6x plus 9, I would put plus 0x squared. Because whether I like it or not, x squared is going to show up in the problem, so will x, so will the constant. So every power of x is going to happen in this problem after the 1st power. So if there's any power missing, you just stick a 0 there just to create space for that object. So if this is written in your book, this is what should be written on your paper. We do want descending order, which means the highest power to the lowest power, cubed, squared, first, constant. If this was in some weird order, like if it said 6x plus x cubed plus 9 plus 5x squared, you want to rearrange it so it was cubed, then squared, then first power, then constant. All right? That's the most important part of the problem. If you don't set it up properly, you can't get the right answer. So make sure as you copy it from your book on your paper, you copy it correctly, and descending order, dividend inside, divisor outside. The division process is right here. This is the division process. That's where it's happening. So every time we divide anything, we're going to do all 4 of these things. And then when we get to step 6, if there's a certain thing that happens, we stop. If not, we got to go back and repeat the process. So again, we're going to be doing the process several times every time. So you're going to get pretty good at this pretty quickly if you pay attention to detail. So it says divide the 1st term of the dividend by the 1st term of the divisor, write the answer on quotient bar. So if we take a look at that step, the dividend is this, the 1st term is x cubed. The divisor is this, the 1st term is x. Okay, we got this ginormous division problem we're looking at, all kinds of stuff going on in it. But I want you to get laser focused on this step. You simply have to divide one thing by one thing. And it's just regular division of letters. When we divide letters, we subtract powers. If we divide numbers, we divide numbers. If we see 8 divided by 4, that equals 2. If we see x to the 8th divided by x to the 4th, that's x to the 4th. Okay, so again, we have different rules for different types of things. So in this case, I'm dividing x cubed by x to the 1st. I subtract the powers. 3 minus 1 is 2, so x squared is what I get. Okay, nothing else in the problem matters in that step. All I care about is what I've got highlighted here, divided by what I got highlighted there, and that divides to something very simple every time. It's very easy to do that. The next step, going back here, says we take that product, take that answer by the entire divisor. All right, so This is my answer, x squared. X squared is my answer. I'm going to multiply it by not just x, but also the plus 3. Multiply answer times both the entire divisor in this case. Okay, so this is just distributive property. X squared times x makes x cubed. X squared times 3 makes positive 3x squared. That's all step 3 is going to be. Take the answer you just got, distribute it, multiply it by both parts of this to get some product, lining up like terms in the process. X cubed goes under x cubed, 3x squared goes under 5x squared. All right. Notice x and x and constant didn't show up, so nothing happened over there. That's just kind of over there out of the way right now. Everything's happening on this part of the problem. Next step. Change all signs of the product. All right, the product is what I've got written in red here. This is the product. I'm going to change all the signs. So x cubed currently is positive. I'm going to make it negative. 3x squared is currently positive. I'm going to make it negative. Okay, back in 4th grade long division, after we multiplied our answer times this, we got something down here. We subtracted it, right? For the sake of algebra, changing the signs takes care of the subtraction phase of this problem. Okay, changing the signs creates the subtraction we want to do. We then have to consider, should I add or subtract the objects based on signs at this point? All right? So changing the signs took care of the subtraction. Now I have to make a decision by combining like terms, should I add or should I subtract? X cubed and negative x cubed are different signs. They're exact opposites, so they actually cancel. Okay. Subtraction creates 0x cubed, but we don't write zeros down. All right? So those cancel. Over here, 5x squared and negative 3x squared, those signs are different signs, so I subtract, and we get 2x squared. It'll be positive because 5x squared is bigger than 3x squared. And then once I've done that, if this is smaller than this, I'm done. That's what it says. If the power here is less than the power of the divisor, stop, you're done dividing. If not, you got to repeat the process. I'm going to bring everything else down, like so. And now I'm back to the first step 2, which says divide the first object of the dividend by the first object of the divisor. This is now the first object of the dividend. Every time I go through a process, what I'm left with is the new dividend. So, what's positive 2x squared divided by positive x? 2x. What kind of 2x? Positive. After the first term, we have to have pluses and minuses in every single term, so plus 2x. Okay. Again, 2 is being divided by 1, which makes 2. X squared divided by x. 2 minus 1 makes 1. So positive 2x is what we get there. We take this answer now, which is positive 2x, multiplied by the entire divisor. So positive 2x times x makes positive 2x squared. Positive 2x times positive 3 makes positive 6x. So we take our answer times the entire divisor to get some product that has some sign on it, positive or negative, based on the product signs, based on the fact that we're multiplying the same sign. Positive times positive makes a positive. Positive times positive makes a positive. Get whatever you get. The next step says change all the signs of that product. So this 2x squared becomes negative. This 6x becomes negative. We combine like terms. 2x squared minus 2x squared makes 0. They cancel. 6x minus 6x also makes 0. They cancel. That doesn't always happen, but it's allowed to happen. It could happen. It did happen. If this said 4x minus 6x, all of a sudden I got negative 2x there. Whatever. All right, it is what it is. You get what you get. All right. In this case, since everything canceled, I'm left with 0 plus 9, so 9 is all that's left. 9 does not have an x, so that means this power is bigger, this power is smaller, right? When the power of this is smaller than the power of that, you're done dividing. I can't divide anymore, I'm done. Okay, so I'm going to stop dividing at this point. Now the final step is to write the remainder term. The remainder term I'm going to do plus or minus based on the sign. Is this a positive or negative 9? Positive. So I'm going to put plus because it's positive. I'm going to put 9, which is its value, over the divisor x plus 3. And that's my answer to the problem. And that's how we perform polynomial long division. It involves a bunch of skills we've been recently dealing with, all put into the same problem. Get lots of chances to practice all these algebraic rules and get really good at them.